Hi everyone. Hope you all had a good weekend. Like I told you in class, I thought I'd try to make some videos so that we didn't waste any time with me not being there these next couple of days. So obviously I've never made a video before. We'll see how this goes, but I think I practiced enough and I think it will work out okay. Just FYI, the fireworks just ended here at Magic Kingdom. It was really exciting. I had to wait for them to end before I could start this video because the noise was too much. Um, can't believe my nieces just slept through that. I'm here babysitting them right now, and they just slept through what sounded like a war outside because there was so much noise. But anyway, not important. Here is what's really important, I hope. Let's see if this works. Oh, yes. Okay. So, this is from your homework. If you guys need to pause and take a second, get your book, get your homework, and so forth, then go ahead and do that. Okay. So this is going over the homework that you had that was due today. So the first one was practice exercise 2 from page 704, I think. I have the question typed in here. It says indicate which salt solution in each of the following pairs forms the more acidic 0.001 molar solution. And then they give us the pairs. Remember that the molarity here isn't important. We just have to decide whether the solution is going to be acidic or basic. So we'll go ahead and take a look at A. Okay, I think it's gonna work. Yay. All right, so crap. Okay. So if we're doing NaNO3, remember what we're gonna do is break this into its ions. So it'll become Na plus NO3 minus. And then we're gonna decide the cation ion, right? The positive ion is going to become the base. So the base that I can think of with Na is NaOH, which by the way is a strong base. And then NO3, HNO3, strong acid. So strong base, strong acid, this solution is going to be acidic. Just kidding. What do we think we do here? Got it. Maybe. Strong base, strong acid. Of course, that means this solution is going to be pH equal to 7 or neutral, right? I'm going to go on to FeNO3. Now, this is actually one that we didn't talk about on Friday. Okay, so when we break this into ions, NO3 minus, HNO3 here, strong acid, that side's easy. But here, we don't really have a base to go to, right? Like FeOH3 isn't a really common base or anything like that. But the book told us that any highly positively charged ion is always acidic. And so since we know that we're not going to worry about our strong side, which is the HNO3, we're going to worry about the weak side, which would be this Fe with whatever it ends up combining with. But it said that highly charged ions like Al3 plus or Fe3 plus are automatically acidic. So that makes this solution acidic. I think the question said which of the following would be more acidic. So the answer here would be FeNO3. Okay, and again, this is because highly positively charged ions are acidic. And so that's why I chose that, because remember, we never account for the strong side. We always account for the weak side, which is going to, in this case, be the Fe3 plus, but it will be weakly acidic due to the positive cations there. Okay, cool. I don't know if I can scroll down. Oh, I can scroll down, but then I won't be able to see. So maybe I'm going to do this. In the meantime, if it's 8th period, someone can lend Gianni a pencil because he probably doesn't have one yet. I'm sure there's a more effective way of doing that, but okay. Here we go. So now we're on to KBr and KBrO4. So KBr, K plus, Br minus, KOH, strong base, HBr, strong acid. So this is going to be neutral solution. Okay. And then KBrO4, K plus, BrO4 minus, KOH strong base, HBrO4, not on my list of 7 strong acids. So I'm going to go ahead and say this is a weak acid. Strong base, weak acid. So this is going to be a basic solution. Again, the question said which is more acidic. So since KBrO4 is basic, the more acidic one is going to be KBr. Even though KBr is neutral, it is less acidic, it's less basic than KBrO4. So that was for letter B. If you guys are having any questions or need to pause, please feel free to go ahead and do that. Just pause and then, ask each other the questions. I'm sure someone in the classroom will know the answer there. Okay. I'm moving on now to, oh my gosh, what's happening there? To C. Okay. So CH2NH3Cl or BaCl2. Okay, so I know my anion is Cl minus, so I guess my cation has to be all of this stuff. Okay, so that's gonna have a plus charge there. HCl, strong acid. I have no idea what this makes, right? I don't know what this makes, but it's going to make a base, and whatever it is, this CH2NH3 doesn't take the form of any base that I know as being strong. Remember, all my strong bases are hydroxides. So whatever base this is going to form, which probably is CH2NH2, methylamine or something I think we might have worked with on Friday, but it doesn't matter. The bottom line is I don't recognize CH2NH3 or any version of that as being one of my strong bases. So I know whatever this produces, it's going to be a weak base, which means weak base, strong acid. So this is going to be an acidic solution. Here, let's see, gotta make it my ion first. So Ba2 plus, Cl minus. That's gonna make BaOH2 and HCl. So that's gonna go ahead and be strong acid. Remember, Ba is in group 2. Group 2 hydroxides are strong bases. So here again, I have a neutral solution. So acidic versus neutral. This is the one that's more acidic, which is what the question was asking. Okay, let's see if I can do this. And now I just want to delete it. Oh, awesome. Okay. So last one, NH4NO3. Sorry, NO2. NH4NO3. and breaking it up. Okay, and here. Okay, this is going to make ammonia, right? Because I'm turning it into my base, and I recognize now that NH4 plus and NH3 are conjugate acid-base pairs. HNO2 weak acid. Remember, my strong acid is actually HNO3 nitric acid, so this is my strong acid. NH3 here. And remember that NH3 is a weak base. So for this first molecule, weak base, weak acid. Oh, weak base, weak acid. Shoot, we're going to have to come back and figure that one out here. Here, weak base, strong acid. So this solution is definitely going to be acidic. Now, I guess I might not actually have to figure this out, because if I'm doing something with a weak base and a weak acid versus a weak base and a strong acid, no matter what, the one with the strong acid is going to end up being more acidic. So I'm going to go ahead and say NH4NO3 is more acidic. In the case of NH4NO2, with my weak base and my weak acid, I would actually have to go in and I think look at Ka values to figure out which one would end up being more acidic or more basic, but I don't often see that situation, so I don't think we need to look into it, considering the fact that we can assume that NH4NO3 is going to be our stronger acid because of the weak base strong acid situation. Okay, let me see how many minutes we're at, because these videos can only be 15 minutes. Let me check that. Okay, so it looks like I'm at 12:20, so I'll go ahead and stop and then start the next video with the next homework problem, because I don't want to get cut off. Again, if you guys have questions about any of what we went over right here, first try to talk to each other, see if you can figure that out. Right now you can pause, have a discussion about it. If it's something that you guys can't figure out as a group, then save it, or you can obviously text it to me or anything like that, and hopefully I can get back to you, or you can save it till I come back. Okay, I will do 1680 in the next video.